All right, I'm back.
Okay, hold on. Let me get my writing tablet going here. What I want to talk about today is equations with two variables in them, x and y. Okay. So far, everything we have talked about, other than the quadratics, or at least everything we talked about yesterday, was equations with one variable only, x. Okay? Well, that always gives you a unique solution for x, either x equals 3 or 10 or whatever. When you have two variables in there, that's the equation of a line. You can't graph that on a number chart, but you can graph it like that in two planes, where the y is the vertical, the x is the horizontal. Now, this is really big in math, this concept of slope and rate of change. So, the main formula you have to remember is y equal mx plus b. What is b?
The y-intercept.
What's m?
The y-intercept.
What's m?
Oh, the slope.
Yeah, m is the slope. Okay, so if I give you an equation like this, and I say plot that, graph it, well, you want to get it into this format. So switch this thing around so that we end up with y equals something. Tell me what I got to do.
Oh, shoot. I don't remember.
Okay, when I'm solving for y, okay, I want the last line of the equation to be this, y equals something. Okay, right now, I have 7x minus 3y equals 8. So how can I manipulate that thing around so that I get y equals something? I got to get rid of everything that's not y. Well, the first thing I run into that's not y is that. How should I get rid of that?
Add to the other side.
Okay, so now we got minus 3y equals what?
Equals 7x plus 8.
It's negative 7x plus 8.
Negative 7x.
In other words, again, I've seen you make this mistake three times. When I'm moving something from one side of an equation to another, always change its sign. If I'm doing it by adding or subtracting, okay? And in this case, I was doing it by subtracting. Okay, now I still have to solve for y. I've solved for negative 3y. How do I solve for y?
Divide.
What's the next line going to read?
1/3.
No, hold on. Dividing everything by minus 3. So I'm dividing that by minus 3 and that by minus 3. Now, simplify that.
No, but could you just multiply it by negative 1/3 and do it all in one
The
step?
same as dividing by minus 3.
Okay.
The reason I call it division is because the way you solve equations is by always doing the opposite of what the thing is currently doing. Right now, that minus 3 is a multiplier. So I've got to divide to get rid of it. Now, it's true that I can multiply by the reciprocal, but that's an extra step. The most efficient way is just divide by minus 3. What's that give me? Y equals what?
Y equals Negative 2 1/3.
Leave it in fraction. Don't convert it to a proper number.
Y equals negative 7/3.
Nope. Do
No.
the sign first. Whether you're doing multiplication or division, give me the sign first. What's the sign going to be?
7/3 positive.
All right. Times x. The rest of it.
Plus 8/3.
No.
Negative.
Negative 8/3. In other words, that becomes negative 8/3 with the negative sign out in front of the fraction. It's not in the numerator or the denominator. All of these are the same, incidentally, in case this is, I think you know this.
Right.
Doesn't matter where that negative sign is. The reason I write it like this is because we're trying to get it into that format, y equal mx plus b. And I do have it in that format. So tell me how to graph that.
So the y-intercept is negative 2 2/3.
Okay, right, we'll call that right there, minus 8/3.
And then up to, and the slope is 2 1/3.
Yeah, leave it as a fraction. I'm telling you, you're far better off leaving these as improper fractions. Do not convert them. What you're doing is converting them to proper fractions. That's never helpful in math. It just isn't. It's always better to leave it as an improper fraction.
So then
What is slope?
And then the slope is up 7/3.
Yeah, slope is rise over run. Notice that slope is a fraction. It is not a proper fraction. It's an improper fraction. In other words, the rise is 7, the run is 3. If you put that in 2 1/3, you can't tell that. So in order to graph it in the xy plane, better to leave it as a fraction. So I gotta go up 7, and which way?
Right.
Right, exactly. So now I'm connecting that dot with that dot, and there's my straight line. That is the graph of that equation, which is the same as this.
I'm going to record you to the very because I feel like standing in front of your building with a sign, don't buy from this company.
All right, I'm going to give you a bunch of slopes. I want you to tell me whether they're plus or minus.
Right. Positive. Negative. Positive. Negative. Negative.
Okay. So we had this. Oh, it's negative 8/3, I think.
Right.
So it's rise over run. I'm starting from down here. I'm going to go up 7. And everybody makes the mistake of saying over 3. You have to know which way. It's to the right 3.
Right.
Because over 3 could be to the left. Now, it's not particularly important that you pay attention to the sign. What is important is that when you're done, you have a positive slope.
Right.
If you have a positive slope, you have done it correctly. In other words, you don't have to remember that it's up 7 and right 3. Just have to remember that it's 7 on the vertical axis, 3 on the horizontal axis, and you have to end up with a positive slope. I actually could have gone down 7 and left 3. And there would have been my second point. I still would have had the same line.
Right.
So these are linear equations when you see a y and an x. And the best way to graph them is to put it in. This might be the only format that they're going to give you on the test that you have to know. There are a couple of other formats, but I would doubt that you would need to know it, not for Algebra 1.
Right.
All right. Go ahead.
What did we go over, I think, 2 days ago? And it was something about like ax plus b times bx minus c or something like that. They had a question or two on the test like that. And then there was...
This is the standard format for a quadratic.
Yeah.
Now, quadratics are one step higher than linear. First of all, they're not straight lines. They're parabolas. They
Yes.
look like that or that or that. Okay? And they have an x squared in them. So we started with quadratics because the only information I had to begin with you was that you wanted to do a little work on factoring.
Right.
Factoring, you got to start with a quadratic to back it up into two linear terms.
Right.
One thing we haven't focused on much is graphing linear equations, and that's going to be a big part of your test. Now, you think you're comfortable with it? You're good with the y equal mx plus b, always knowing how to graph it? What if I gave you a graph? Before we go to the quadratics, I'll go anywhere you want, but I'm going to give you a line, and you tell me what the equation of that line is.
All right. Can do that.
I'll give you another point on that line. Tell me the equation of that line.
Okay.
Start with this. Always start. Best way in math is to start with the general equation, always. And then just try to fill in everything you can. Well, what's B?
Wait, is that first set of points, is that 0, 2?
Well, it is. I didn't label it like that. Is all I put is the y-axis on, or the y-intercept. But you're correct. That is 0, 2.
All right. The slope is 2/3.
Nope. Oh, hold on. You're absolutely right. The slope is 4/6, so the slope is 2/3. So what's the equation?
Y equals 2/3 x plus 2.
All right. Well, good. It looks like you got a decent handle on graphing in the XY plane. All right. How about absolute value? I'm not trying to get away from quadratics. We'll go back to that. But have we talked about absolute value in the last?
No, I was going to ask you about that also.
Let's talk about that.
Yeah.
Okay. Let's start with a very simple one. When you have absolute value in an equation or an inequality, it means two things. You have to list what each one of them means. What are the two things that this means?
Oh.
It means x minus 7 equals what?
8.
Or what's the second thing it means? And I write it this way for a reason. And
X
never
plus.
change what's inside the absolute value.
Or x plus 7 equals 8.
Never change what's inside the absolute value, ever. You just changed it when you said x plus 7.
X minus 7 equals -8.
Yes, you always change what's on the other side. Okay? Now solve both of those vertically. The reason I write them horizontally is because I know I'm going to have to solve them vertically.
Yeah.
So x is equal to what? On the left.
1 or -1.
Nope, made the same mistake again.
Is there two answers?
No, well there are, but I'm doing the one on the left.
Okay.
Solve the equation on the left.
X equals 15.
Okay, or
15 or -1.
there you go. Okay, so that's the essence of absolute value equations. If I say absolute value of x equals c, that means x equals c or x equals -c. Really no harder than that. Okay? Now, let's talk about absolute value of inequalities. Slightly different, slightly harder. What two things does this mean? It means x minus 7 is what?
Greater than 8.
The first thing it means is always what you're looking at without the absolute value sign.
Right?
Correct. Okay? The second thing is a little harder here. Again, never change what's inside the absolute value. So what's the left side going to be?
X minus 7 is greater than -8.
In inequality, you have to change two things on the right.
Oh,
You have to change the direction of the sign and the sign on the number. So it's x minus 7 is less than -8.
Okay.
Okay. So this one comes out to be x greater than 15. You know, maybe I'm confusing you a little bit. I don't know. You tell me. If you
No.
do it this way, do it that way.
Yeah, but I'm not writing that.
Okay. But even in your mind.
Okay.
In other words, the mistake it looks to me like you're doing is you're moving the -7 to the right side without changing its sign.
Well, you only have to change it,
always change its sign.
even if it's not a inequality.
Yeah, even if it's an equation. In other words, I'm going to move that 7 to the right side. I got to make it a +7. Right now it's -7.
Oh yeah.
Okay. All right. Same thing over here. If you're more comfortable doing it that way, do it that way. Or if you're just going to do it in your head, move that 7 to the other side, make it a +7. And now you get x less than -1. Now notice if I happen to graph that on a number line where that's 0, there's -1, here's 15. Notice the solution. It's x is greater than 15 or x is less than -1. So that's the graph of that. Again, notice only one variable. We're going to be able to graph the answer on a number line. If I have both an x and a y, then I got to graph it on a xy plane. Okay. That pretty much covers absolute value. Those are the only two things you're going to need to know about absolute value. Just remember the side on the left is always exactly what you're looking at without the absolute value sign. And then the side on the right is different on the right side only. The left side is still the same without the absolute value. Okay.
Yeah, they tried to make it kind of tricky on the test by adding a y variable. Like, let me read you this problem they had.
Go ahead. We can do these in 2 dimensions. What I just was doing was 1 dimension. Okay, go ahead.
Yeah. x cubed plus xy squared minus 1, or no, minus the absolute value of negative xy plus the absolute value of y squared minus x squared, and then it says 8 plus 36 minus the absolute value of negative 6 plus the absolute value of 5.
Is this an expression or an equation? What is it?
An expression.
Okay.
And then they had me solve for x and y.
You can't. It's not an equation.
They had two answers. So
Well, if you make it an equation, then you could solve it.
okay.
Although this is like a 9 on a 10-point scale, and we're talking 1 and 2 here. So either this test is not Algebra 1, because I don't know what this problem's doing on there, especially if it's not an equation. If it's just an expression, then the goal is probably to simplify it, not to solve for it. You can't solve for stuff. If I tell you this, there's no way you can solve for x and y. I haven't.
No, there's more to that here.
No, I know. You read it to me. It's just it was so long that I can't believe this was on your test.
Yeah.
Hold on a second. And I'm not sure this is useful to us to talk about this stuff. Seriously.
Well, there was only one question like that.
Yeah, well, that's your highest degree of difficulty. That's not what you need to learn. What you need to learn is all the easy and medium stuff. If you're just trying to get a 65 on this test to get into that school, then forget about these kind of problems. We're not going to waste your brain power on these.
All right.
Okay, let's talk about the stuff that you haven't had for 2 or 3 years. Algebra 1.
Yes.
However, let's go on.
I can
Be
read
pretty solid in y equal, in other words, in linear functions.
Yes.
Solve that for y.
All right.
A little harder. Actually, not that hard. Just go ahead. Remember, when you're solving equations, this is what you want at the end. So how do I get that?
I think I found y equals -1.
No. Go step by step. There's your equation. Give me the second line.
xy equals x minus 1.
No, it's actually 1 minus x.
Does that make it? Oh, that makes a difference.
You see? Well, actually, it does, but it's still not -1. But make sure you get those right. You can't afford to get those mixed up. You're going to get the problem wrong if you don't get these right. In other words, it's not x minus 1. I have to subtract that x to get it to the other side, which means I got to subtract it from over here.
All right.
Okay. Now solve it for y. What do you get?
1.
No.
Positive 1? No.
First of all, how am I going to solve that for y? What's the y currently being? What's stuff doing to the y?
It's multiplied by the y.
So I got to divide by x to get rid of the x. That's my goal, is to get rid of the x, right?
Yes.
Okay. So if I divide the right side by x also, that's my answer. 1 minus x over x. Now, the way you may have come up with 1 or -1 was you may have canceled these x's. You can't do that.
Yes. Okay.
Okay?
Right.
In other words, the only thing you're allowed to do with a fraction is multiply it by 1 or divide it by 1. So I can certainly divide top and bottom by x, but what that gives me is 1 over x minus x over x which is 1 over x minus 1. So that's another way of saying this same thing.
Right.
But it's not just minus 1. In other words, you cannot do that kind of stuff. If I tell you x plus 2 over x plus 3, you can't do that and come up with that. That's not a you can't do that in math.
Alright.
Okay, and remember that. A lot of people make that mistake. So you can never do that. The only thing you can do is divide top and bottom by the same thing. So if I have x plus 2 over x plus 2, well, I can divide the top by x plus 2, and I can divide the bottom by x plus 2. Now I end up with 1 over 1. So I can get to 1 when they're the same thing in the numerator as the denominator. But when they're totally different, be careful. Don't make that mistake.
Okay. I have another problem in here.
Go ahead.
It is, we might have done something a lot like this, but it's just 3x cubed minus 2x plus 5 over x minus 3.
Okay. This is how we're going to do this.
Well, don't we need the ghost binomial?
Yes, we're going to do long division because I can't really factor that numerator.
Yeah.
Sometimes these kind of problems are just factoring problems. And if you factor the numerator, you find an x minus 3 factor, which cancels with this x minus 3, and you're left with a nice simple answer. But on problems like this, the only thing you can do is long division. You have not learned synthetic division yet, correct?
No, I've learned it.
Okay. Are you going to need to know it on the test?
They didn't. I don't think they had any problems that said use synthetic division.
Well, then we've talked about long division. I would say let's stick with long division because it'll take me 20 minutes to teach you synthetic division. And if
But
you
long
don't have to
division,
use synthetic division, let's not use it.
but does long division accomplish everything that synthetic division can?
Yes.
Okay,
Exactly.
that's fine.
They're no different. The only difference is they take the variable away, they change the sign, and everything's adding instead of subtracting.
All right.
Okay? And I'm happy to go over synthetic if you want to just review it, but tell me what I need to write. Let's first of all do long. We're going to review your long division.
Yes.
Tell me what
3x
to write as the dividend.
3x cubed plus 0 minus 2x.
It's 0x squared.
Okay.
What else?
Minus 2x plus 5.
Okay. Tell me how to do this. First step.
First number that we're going to bring to the top is 3x squared.
Okay, I'm going to divide x into 3x cubed. That's the first step.
Yes.
Now what am I going to do with that 3x squared?
Multiply it back, get 3x cubed minus 9x squared.
Now you can see why we need that x squared. I'm going to subtract like terms. If I just had a 0 there, I'm subtracting the x squared column. Okay? So what next? What goes below that line?
X squared. Just x squared.
Okay, hold on. What is 0? Subtract.
Oh, that's a 0. It looks like a
minus
10.
9.
It's a negative 9x squared.
No.
0, oh, 9 squared.
9x squared.
Okay.
Okay, this is 9. Again, do not drop a negative. Got a negative right there, and there's a hidden negative right there because we're doing subtraction at every step.
Okay.
Okay. So
now I bring down this.
Okay.
Bring down the negative 2x, right?
Okay, just one term at a time. Only bring down one term. Repeat.
Only bring down one term.
Now divide. In other words, start the whole process over again. What's the next term in the numerator?
9x.
Plus or minus?
Plus.
I need that plus. It's part of an expression, part of a polynomial. Okay, now what?
9x squared minus 27x.
Gone?
$25x plus 5.
Yeah, bring down the next term. Repeat.
Plus 25. Minus 25x.
Actually, it's plus, but go ahead.
Plus 25x. Minus 75.
Yeah, in other words, don't drop negative signs, but don't add negative signs either.
Right.
In other words, that 25 times x is plus 25x. It's just we're subtracting at every step here. Okay, so once you subtract the last thing, what do you get for a remainder?
You get 80.
Okay, and the way that's written, in other words, we don't say just remainder 80. What we want to say is we're adding this fraction to that polynomial, 80 over x minus 3. So there's your full and complete answer. Okay, the only way to really get that is by division. Now, as long as we talked about it, you want me to just do this real quickly, synthetically, so you can see that it's basically the same thing?
No,
Okay.
not really.
All right. I won't do it. I don't want to cover areas that you're not going to be tested on. Let me give you some other problems, though. It's very important to be able to solve equations. Okay?
Well, there's only one more thing on this paper that looks like
Okay.
it might trip me up, and that is 7 over x minus 3 times x minus 2 minus 5 over x squared minus 6x.
Okay. X squared minus 6x? Or x squared minus 6x plus something else?
No, just x squared minus 6x.
All right. So, did I write it correctly?
Yes.
These are normally first step factoring problems. First of all, in order to subtract two fractions, I'm going to need to find a common denominator.
Huh.
The easiest way to do that is to factor the only thing that can be factored. They've already factored the left fraction for you, but the right fraction can be factored. Factor that. There you go.
Do I have to complete the square?
No, just factor it. Greatest common factor. Always think greatest common factor is first thing you look for.
X
Times what?
times x minus 6.
Okay. Now, I've got two fractions with two different denominators. So what is my common denominator going to be?
X minus 6. You have to multiply the two denominators.
Multiply all of them together. None of them are the same. So I've got an x times an x minus 6 times an x minus 3 times an x minus 2. That's my common denominator. And it's the least common denominator. I can't find anything smaller than this that is divisible by all three terms, or all four terms. What goes right here? 7 times what?
Times x minus 6.
Yeah, and notice the advantage of writing it and leaving it in factored form. You can instantly tell that that's the same thing as that. And that's what's important whenever you're doing these problems. Make sure you do not change it from one row to the next. That's the goal. You change it, but you don't change the value of the fraction. This fraction is the same as this fraction. So what goes over here?
Five times x minus 3 times x minus 2.
Perfect. Again, you can see you have not changed it. Okay? Now, the next step, we have a common denominator. We're not going to do anything with that denominator. We're going to leave it alone, and we're going to operate on the numerator. Well, let's see. I need a little writing room. So let me erase this over here. So if I operate on this, tell me what that is.
I'm just simplifying it, basically.
Yeah, this becomes x squared minus 6x multiplied by 7. In other words, let's replace that immediately with x squared minus 6x, the whole thing multiplied by 7. So what's that give us?
7 times x squared minus 6x. 7.
That 7's got to multiply by that minus 6x.
All right, 7x squared minus 42x.
Now, the right side. These two things are being subtracted. You have to be extremely careful here that you put parentheses around everything on the right numerator that's going to be subtracted. Well, first of all, if you multiply that by that, those things, you get this.
Well,
I'll
now that we have
speed it up a little bit.
So now that we have the same common denominator on both sides, they can just cross each other out.
Nope.
Kinda.
Can't do that yet.
Right.
No, this is our common denominator. There's nothing that crosses out. We don't want to cross it out where we can cross it out because we're trying to subtract these two fractions. We've got to have a common denominator, otherwise we can't subtract fractions.
Okay.
So whatever the numerator is, it is. We don't want to then go backwards and cross it out. Okay? What we want to do now is simplify the numerator. So the first step is I multiply that linear factor by that linear factor. I get x squared minus 5x plus 6. And I multiply the whole thing by 5. That gives me 5 there. 25 there. Makes that 30. You with me?
Yep.
So that's what goes in those brackets. And the reason I have brackets or parentheses around it is because all of these things are being subtracted. So remove the brackets, what do you get? Remove the brackets. It's always the next step in these.
So then we're combining alike terms.
No, not yet. Just remove the brackets.
All right. 7x
minus 5x squared.
Minus 5x squared.
Just pick up from this point.
minus 25x.
No. That's why I'm belaboring this point.
I
This
don't get it.
negative sign that's in front of the brackets has to be applied to every term. So it's minus, which turns that into a plus.
Okay.
X and minus 30. Okay. Now, simplify that. Hold on. Remember, this is just the numerator. In other words, this is what I'm going to replace above the line when I'm done. I'm going to have that common denominator still, but I'm just replacing the numerator. So simplify that.
2x squared.
Do it one type variable at a time. In other words, you got a couple of x squared terms. How many total x squared terms are we going to have?
Just one.
What is it?
2x squared.
Okay, now go to the x terms. What's our total x terms?
2.
There's two of them. What's their net?
Negative 17x.
And numbers, total numbers.
1. Minus 30.
Okay. Now, this is possibly the final answer. The only reason it might not be a final answer is if this numerator factors into a factor that I can cancel with one of these factors in the denominator. Let's see if it does. So let's try to factor that numerator.
Okay.
We're starting with 2x squared. This would be good practice at factoring again also. We can factor that. What's it split up? What's the x's split up to?
Because we can't take out a greatest common factor.
Good. Step one. Can't do it. It's not difference of perfect squares. We can't factor it that way. The only thing we can do is quadratic factor.
What? Can we regular factor it?
That's what I mean by quadratic. Yeah, I didn't mean the quadratic formula. In fact, if you have to use the quadratic formula, then you're not going to do it because there's no way you can come up with a linear factor. The only reason we're even giving time to try to factor that is just on the offhand possibility that one of the factors is x minus 6, x minus 3, or x minus 2.
One of the factors is x minus 6.
So this has to be plus 5.
Yes.
It does not produce a minus 17. It's the reason you don't do it all in one step in your head.
If it's
it's got to produce that middle term. If it doesn't produce that middle term, it's wrong.
Okay.
Okay, the one thing we know for sure is the only way you can break up 2x squared is 2x times x. Signs have to be opposite, but they could be minus plus just as easily as plus minus, and it would be different. Now we're looking for factors of 30. Well, I'll start with 6 and 5, but notice that ain't going to get us up to minus 17 no matter how I put it down there. Because 6 times 2 is 12, and then I'm subtracting off the other end of it. So how about we try, well, let's, first of all, we got 31, we got 15, 2, we got 10, 3, and we got 6 and 5. 10 and 3 looks like it might work. How?
2 times negative 10, or 2x times negative 10.
Okay.
Minus 3x.
That produces a 17.
Mm-hmm.
And it's a negative 17. So that's what you have to do when you have a problem like this. Now, since the only factor that could possibly cancel out with the bottom would be that one, it doesn't. There's no x minus 10 in the denominator, meaning this is our final answer. We don't need to factor it. We could put the answer down like this, 2x plus 3 in the numerator times x minus 10, but that doesn't really help us. We can't cancel anything more out. Because all it does is just fully factors it, and I don't know that that's needed.
Okay.
Like I said, the only reason you'd even give it 20 seconds worth of time was on the slim possibility that one of these factors would cancel out with the bottom. And what I have found is in 10 years of tutoring, that almost never happens. It just rarely happens. In fact, it's pretty rare that it even factors. This one happened to factor nicely, but it still doesn't cancel out with anything in the bottom. Notice nothing. I cannot do anything with this x minus 3 down here on the bottom or this 2x plus 3 at the top. They have to be the same to cancel out. Unless you have something like this. What's that equal to?
1.
Minus 1. Always.
Because you were just...
Only time you can cancel a numerator with a denominator out, and they are not exactly the same, is this scenario.
All right.
Any other time, they have to be exactly the same. And this one doesn't cancel out. It changes to minus 1. Which is different, because if you cancel it out, if I had x minus 3 over x minus 3, that becomes plus 1.
Right.
Okay.
One thing on here looks kind of different. We probably went over it. It's a to the negative first power plus x to the negative first power over x to the negative first power.
All like this?
Yes.
Okay. So, convert all of these to positive exponents. What is a to the minus 1?
0.
No.
1.
That's 1 over a to the positive 1. In other words, that's all a negative exponent is. If I told you 2 to the minus 3, that is 1 over 2 to the positive 3.
Okay.
Okay, very important principle. That's all negative exponents mean. They don't mean negative numbers. Notice, never do they mean negative numbers. Well, I shouldn't say never, but in order to do this operation, we've got to convert it to 1 over a. Well, what's the next thing?
Plus 1 over x.
Correct. Again, get rid of those negative exponents. All over what?
All over 1 over x.
Correct. Now, it may look like we've made it more complicated, but at least now we have a way of doing it. I know how to add those two fractions. Now, do I have to add those two fractions and go to the trouble of finding a common denominator?
No.
No, because the bottom is a single quotient. So how do I divide by a fraction?
Multiply.
By its reciprocal.
You can't just cross out the 2
No.
1 over x.
No,
Not
not yet.
Alright.
What you can do is you take your division problem and you turn it into a multiplication problem, because that's much easier. And you multiply, but you have to multiply by the reciprocal. You can't multiply by 1 over x. You multiply by x over 1. Now that actually gives you a pretty good answer because just distribute it. What's that?
X.
No.
1x.
It's x over a.
Oh.
And then what is this? You've got to distribute it to both terms.
1.
Exactly. There's your answer. So we came up with the answer without having to go through this process of adding those two fractions. But let's do it anyway. You need a little practice at adding fractions. If I'm just going to operate on that numerator, what's the common denominator?
AX.
What goes in the upper left numerator?
A. Or X.
And what goes in the upper right numerator?
A.
Okay. So the problem now is this. Okay. And if I simplify that numerator, what do I have? I have x over here on the left. I have x plus a over ax, all divided by 1 over x. So I'm going to multiply by the reciprocal, x over 1. Now that x crosses with that x, and I end up with x over a plus a over a, which is 1. So I get the same answer, but it was harder.
Yeah.
Now, if you reverse these and you said 1 over x all over this, you cannot reciprocate and multiply until your denominator is a single quotient. In other words, change the numerator and the denominator in this problem, and you have to do it the hard way. You have to do it this way where you find a common denominator. In other words, because my denominator would be 2 terms and not just 1 term, it would be 2 fractions, you got to combine those 2 fractions before you can reciprocate it and multiply.
All right.
Okay. Got any last things?
Yeah. Okay, just one last one.
Okay.
It's the parentheses 3 minus root 2 times 3 minus root 2.
Okay. FOIL. You're multiplying a binomial term times a binomial term.
All right.
You're going to multiply every term by every term. In fact, I prefer ET to the words FOIL, although I've been thinking about that lately, and FOIL actually is pretty specific here. Well, multiply, what's the F give you?
9.
What's the O give you?
3 times negative root 2, which is, I don't know.
Negative 3 root 2. That's how you write it.
All right.
Don't convert it to a decimal. They do not want you to do that. Okay?
Right.
The next term?
Next
I
term,
FOIL? Yeah.
negative root 2 times 3.
Which is?
Is it negative 3 root 2?
And finally, the last term, the L of FOIL.
Negative root 2 times negative root 2.
Sign first.
What?
Give me the sign of the answer first. Is it a positive or a negative sign?
Positive.
What's the number? What's root 2 times root 2?
2.
Combine everything.
9 minus.
Okay,
How do you combine those
combine
terms?
that and that. They're like terms.
All right.
So 11.
11.
That and that. Now what?
How do you combine those like terms?
Well, they're like terms. If I call that an apple, and I call that an apple, then I got minus 3 apples, minus 3 more apples.
Minus 6 root 2.
There's your answer. But
Okay.
this is a very important point. The root of x times the root of x is equal to x, no matter what x is. So if you
Alright.
have root 7 times root 7, it's 7. If you have root x times root x, it's x. So the root 2 times the root 2 is always going to be 2. And the only thing you have to get right is the sign. In other words, it was a minus times a minus.
Alright.
Okay?
Thank you.
Well, Nathan, good luck. What time do you take your test?
In a couple hours here.
Okay, well, have a good lunch and
Thank you.
clear out
I'll
your
let you know.
brain. And good luck. I hope you get in. That sounds like it'd be a pretty cool place to go to school. I took my kid to Roswell a few years back. Went and visited the alien museums and all of that. It was fun.
Yeah. Oh, it's a cool town.
Yeah, it is. It is.
Thank you.
You're welcome.
I'll let you
Have a good one. Bye-bye.
Bye.